Welcome everybody to this TechNovation talk. The title of this talk is Enterprise Artificial Intelligence with Open Source Software. Really? Can we do that? So I welcome you all to this TechNovation talk. For your information, this event is recorded and we'll be able to replay it at home afterwards. And I want to mention to everybody who's listening that this is an event that is a side event of a conference that's taking place today and tomorrow at the UN called the OSPO for Good conference. So it's a really interesting conference. I encourage you to check it out online. It's OSPO for Good, and it's all about open source and how open source can help us advance the Sustainable Development Goals. So as part of that, we have some great guests coming here at the UN these days. And I want to start by introducing myself. I'm Jorge Martinez Navarrete from the Innovation Unit in the Office of Information and Communication Technology. And this event we're having this event in cooperation with the United Nations 2.0 initiative. And for that, I want to introduce my colleague, Julia, who is going to say a few words about the UN 2.0.
Thank you so much, Jorge, and thank you everyone for joining. My name is Julia, and I'm the lead of the UN Digital Community. So I'm quickly going to share my screen for you and share a little bit what the community is all about. I hope you can see the right screen right now. Maybe give me a quick thumbs up. But yeah, this is one of the 5 UN 2.0 knowledge communities, and we are welcoming colleagues from across the UN entities who work in digital and are interested in connecting with fellow practitioners, learn more about digital programs across the UN, and embed a digital mindset into UN culture. We also welcome external perspectives. And so today we have invited a select group who had registered their expertise and interest in AI. And so we're very happy to see so many of you log on, and I can see the numbers are still going up. So I don't want to keep us from a fantastic session that Jorge and the team have prepared. So I want to hand over back to him, but I do want to encourage you, if you have not joined the UN Digital Community yet, please do so. The link is up on the screen and also will be in the comments. It'll just be a great opportunity for some knowledge sharing and peer-to-peer learning. And so with that, back over to you, Jorge.
Thank you, Julia. So we're going to start getting into the topic now. So enough blah, blah. So there's an entire conference covering open source and AI downstairs. So here we're going to talk technical. This is a technical talk. I want to introduce the project a little bit. So in organizations around the world, people are trying to, of different sizes, how to leverage, in particular, generative AI, for text generation and for multimedia generation in corporate context. This can be inside of government offices or inside of companies. And it's very convenient to use third-party OpenAI service provider, AI service providers, such as OpenAI or others, and they get you very far. You can do lots of things with those third-party services, but there's a point in which organizations want to keep their data confidential. They want to be in control. They want to own their AI. So this project is about that. And I just want to say something that somebody in the conference today mentioned is, well, this is great because it's about AI, open source, and governments. How can governments leverage this technology? This is an angle that I really want you to explore, Arun. And with that, I want to mention that Arun Gupta from OpenIntel is also a thought leader in the OPEA project, which is the Open Platform for Enterprise AI. This project has been launched recently by the Linux Foundation, and I'm sure we're going to hear more about that. And why are we focusing on this project? There are other actors in the private sector that are developing open source tools for generative AI. And one of the reasons is that this team is backed by very solid companies. So that's one aspect. And the second aspect is that they have a very clear, defined open governance And this is really why I'm interested in this project, because this is not an open source project led by an individual or by a company, but rather by a consortium of companies that are operating under the Linux Foundation, which has a whole history about managing projects with open governance. With that, let's get to the topic. I want to introduce my two keynote speakers today, Mr. Arun Gupta, Vice President and General Manager of Open Ecosystems in Intel, and Dr. Malini Bandaru, who's a cloud native architect and senior principal engineer at Intel as well. So over to you, Arun.
Thank you. Thank you, Jorge. I'm really happy and excited to be here. I think it's a wonderful opportunity. And as Jorge said, this is part of the bigger OSPO for Good initiative. And the keynote this morning was very inspiring. Everybody that we heard from were talking about AI is a challenge that is a global challenge. And the way to bring about the global challenge together is really open source community. So I think in that sense, this project that we're going to talk about, how do we do enterprise AI with open source, is a really interesting mix here. We have a very interesting lineup for you. I'm merely sort of the pretty face on the picture here, but all the hard work is done by a very impressive team behind. And so they're going to be talking through it. We're going to talk through what the project is. And the most interesting part of the talk is not about the project, it's about what can be done with it today. So we're going to spend significant amount of time showing you what are the technical details, the juice of the project is, because Technovation is about getting into the technical details part of it. So we're going to show you a range of platforms on which this OPIA project can be deployed, a diverse range of hardware, software architecture. And what's going to make this project successful is your collaboration, is your feedback. And I think I want to emphasize the part about open governance. There is no other way we would run this project. The project is done in a very open manner. Anybody can collaborate, anybody can submit a pull request, whether it's a code, whether it's a governance, or it's an issue or a feature in that sense. So without much further ado, I'm actually going to hand over, I'm going to run the slide. I'm going to be the slide jockey, but Zive is going to cover the first part of the slides, where he's going to talk about what the project is.
Great.
Zive, take it away, please.
Yes, and Zive, just for logistics, I'm timing 10 minutes for talking. So make sure that we do all the talking in 10 minutes, and then we'll go into the workshop. Okay. So time is running.
Arun, you want to share the deck to the audience, or?
Yeah, I'm sharing the deck. Oh, am I not sharing?
Oh, we don't see that. Yeah.
Oh, okay. Sorry, my bad.
No problem. Just in the meantime, hi, this is Zhiwei. I'm from Intel. I'm the product manager for the OPA. My pleasure to present you the product idea.
Yeah.
And the rest of the team will also show you some of the demos for the product later in the session.
Go for it.
So, right.
I am sharing the deck now. Yeah.
Yeah, you hear me well, Arun? You hear me?
Yeah, I'm sharing the deck now.
No, I see. Okay, I see that. Thank you. Cool. As we said, the Gen AI is pretty new, pretty popular, it's pretty complex. Nevertheless, enterprise and government data is super critical. We want to own that AI system. Since GPT 3.5, since launch in the end of 2022, the AI ecosystem is running so rapidly. We have large language model coming to the market in a weekly basis as of today. Nevertheless, today's AI system, Gen AI system, is not just the large language models. It's a very complex and a compounded AI system that consists of a lot of components, like the vector database, embedding models, retrieval, re-ranker. It's a very complex system. So how to make it simple for the enterprise AI who may not necessarily have all the highest the AI expertise? So the overall product idea for the OPIA is to make it open source and make it easy to use for the enterprise and the government. So how we can build a Gen AI system in a configurable, composable way is the entire product idea. Then we go to the next page. Let's look at what Gartner say from a market research top line perspective. What are the top technical issues when enterprise want to build the Gen AI system? The top three things you will see here in the top is the technical implementation, whether the entire system is complex. And second, the operating cost, the product cost is increasing. And the third, do the enterprise OEM or the ISVs have the right talent to build a Gen AI system? With all this together in a nutshell, if an open ecosystem that can really offer a reference implementation for the Gen AI, and each of the microservice component is really configurable and composable, so that enterprise have the flexibility to choose the component they want, that would significantly reduce the barrier on the technical side and also the product cost side. So that's also the background for the why we come up with such a product idea on the OPIA. Next page, please. Let's see the top feedback we got from ecosystem vendors and customers. What are the top issues on a complexity perspective? First of all, it's not easy to use. The entire system is complex and compounded. And how does ecosystem, what model we will use? We will use open source model, we use closed source model. If I build up the system, how do I scale the system? Is the system secure enough to really protect my enterprise proprietary data? And how do I maintain the entire flow? That's super critical on the first bullet point. And the second is on the return on investment. How can I bring fast to market? How to with a qualified performance result in terms of latency and tokens throughput? Super critical for the entire cost. How do we have the qualities, ensure the quality, and also to lower the hardware cost and operation cost, return on investment? Security is another important piece. How do I deploy the entire rack system? And where do I deploy my model? Is on the cloud? Do I use the public cloud? Or do I set up the on-prem hosting for my model? How do I build an end-to-end pipeline for my data security? And last but not least, I want to build the entire use case end-to-end, and I want to have control of it. Next page, please. Before we look at the entire OPIA product, let's take just an example about a rack system, one of the most popular system when we want to do the Gen AI. Whether we use a rack, which is today's most popular, and going beyond, we're also thinking about fine-tuning a long context window AI agent. But rack as a first step is showing this architecture, showing how complex it is. So we have so many building blocks, and in future the microservice in the place to come up with the entire architecture. So when a user want to ask a question, a query to the large language model, and send the information to the embedding model, and the embedding model will process it, bring it the text version, tokenize it into the vector database. And then they will retrieve the data from the enterprise proprietary data called the data ingestion and the processing. After that, we need to retrieve and rerun the entire search in either similarity or thematic way, so that we can get the best matching result. And then we process the prompt, send it to a large language model. We add a guardrail to reduce the hallucination, and then we send it to user, get the feedback, and that's the entire AI pipeline, consisting of 9 or 10 different building blocks. And how to fine-tune, maintain every building blocks to perform really the qualitative result is the most important thing. This is just example. Eventually, on the rack system we build as a first step for OPIA, each of this dotted line you will see is a kind of a microservice we will prepare for the open ecosystem to choose in a configurable and composable way. So eventually you will use it in a very easy use manner. That's the entire product idea. Okay, then we will go to the next page to see what OPIA it is. So in total, we have 2 pages telling what OPIA really is. OPIA has 2 main core product elements. We have a construction piece of the element. So how do we build the entire AI solutions? And the second, we also have the evaluation piece. Once you build a product, the Gen AI, how do you evaluate? So on the construction side, our main focus is build it composable and configurable so that the ecosystem can cherry pick and easy to use. So what we have here is that on the building block, like the Gen AI models, the large language models from open source, like the Llama 2, Llama 3 open source model, most popular one, the Mistral one, the COE model from Mistral, and also from Microsoft Phi and bunch of others open source models. And going beyond just LLM, we will also scale it beyond to the vision models, like Stable Diffusion models. And we were even thinking about to support some of the popular closed source models in the mid-long term. Going beyond, let's look at the system component. Taking RAG, for example, the embedding models, we will select the ecosystem vendor, the embedding models, vector database. Later, we will have a charter show what are the ecosystem partner names for each of the building blocks. For vector database, we'll have PyCorn, like Trauma, like VV8. So it's in our release, re-ranking, retrieval, and post-processing, and more. So for each of the use case, we will prepare the building blocks and sufficient building blocks for the customers to choose. And RAG is just the first step that we build for Joint AI system. If we scale beyond, we will also support fine-tuning pipeline. We will also support multimodality with videos and the image, and also AI agent, either single agent and multi-agent will be in our entire roadmap to show. The most important, we want to build end-to-end Joint AI flows. On the evaluation piece, once we build the Joint AI solution, how do we evaluate? How do we show the benchmark and the matrix from the performance, from the feature, from the security trustworthy system, from the enterprise readiness perspective? We're just building such a measurement matrix so that we will evaluate, provide sufficient parameters to evaluate the Joint AI solution we built earlier. Next page, please. This is the high-level OPA roadmap. It's super high level. We're building a detailed level to be released later. But for the general idea is in 2024, we're just getting started. And we're preparing the pipeline and the framework to build the RAG system as step one. So the RAG system is step one. Moving forward, as we said, in the second half, we have the fine-tuning already prepared in the pipeline, multimodality, the AI agent, super hot and popular case for the Gen AI. And last but not least, we have the evaluation benchmark. Starting in the Q4 2024, we will try to scale using all these technical building blocks. How can we scale this into the different vertical use case? So we're setting up the different verticals and aligning with the ecosystem partners to solve the industry real challenges. So it's not just a technical perspective. So how can we scale it until to the product and the business perspective is what a vertical use case working group are focusing on.
Yeah, we're hitting the 10-minute mark here. So.
Right, that's exactly. I will hand it over. I'll hand it. It's like a rehearsal. Okay. We hand it over to our chief architect, Malini.
Hi, everyone. So this is a quick look into what's there in open source today under OPIA, the Open Platform for Enterprise AI. As you can see here, we have basically Gen AI examples. This is the starting point. These are some reference implementations. We have components. So think of components as the Lego blocks that you use to create your whole Gen AI application, which are the Gen AI examples. We have some documents right there, documentation to create a Kubernetes cluster, to launch something in Docker, to use a chat Q&A type of example. We have to get into Gen AI evaluation, responsibility, accuracy, hallucination, etc., etc. And then we also have governance. As Jorge and Arun have mentioned, it's all about open governance, and we seek and take input from all of you in this space. Next slide, please. Just a quick look at our technical steering committee. It represents both technical expertise and end user communities, and people like Steve Grubb from Red Hat, who's a partner on security and ease of use and things like that. So just a quick look. We have folks from Fidelity, from Comcast representing end users, from system integrators like CDW, Nathan over there. We have Llama Index's Logan. We have Docker and JFrog from end user communities and ease of use. Next slide, please. So what are our responsibilities as the technical steering committee members? what's the technical direction of the project? What are sub-projects? What are the requirements for the sub-project? What should their goals be? And there'll be also working groups. I won't go deeper into this, but all these are online, and these are our guiding principles and how we want to serve this community and our whole industry and the global community much better. Next slide, please.
And maybe one point worth mentioning is, open governance. All the TSC meetings are also public. So anybody can join and participate, and they're recorded, and the recordings are available. So you're more than welcome to participate. Why did you make this call? Why did you? And we talked about ethics and responsibility and all, and the transparency. So this is exactly how we want to run the project as.
So just focusing on that, do you often accept pull requests coming from someone who's not in the core team? Does that happen?
Absolutely. Yes.
Yeah.
Every
I'll
pull
let Molly
request will be, sorry, every
No,
pull
go ahead.
request will be reviewed by at least 2 people for technical content, clarity, following, the right way we like to code and things like that, and end-to-end test cases. But every contribution is welcome and evaluated and then accepted. And we even have design requests, so you have a slightly larger project to provide a design, and then we review and we go from there. So everything is in open. Hector, please join too.
Like we were talking about the work that your team has done.
Mhm.
We would love to take that as a pull request into the project itself, so that it's not just UN, but the rest of the open source community can leverage and benefit from it.
Great. And I think for the audience who's watching and not part of the team, a pull request is when you can actually contribute code to an open source project, and the core team reviews your code, and maybe you can become a contributor. And I think this is part of what we want to do here, to encourage the community to contribute to this open source project.
Right. And if you are interested in contributing to the code, by all means, reach out to Malini or myself or anybody else over here on the call.
Good.
We would be happy to kind of guide you through that process. What does it mean to make your first open source contribution? We'll be happy to walk you through the process.
Super.
We invite, encourage, and these are our partners, a whole bunch of them like Neo4j, CDW that I mentioned, Llama Index, and so on. So with that, I hand off.
Yeah, and I think the richness of partners here is important to understand, Hooray, as you were talking about. We have companies like VMware and Red Hat and all, inclusive and incorporated as part of it. We're looking at database vendors. We're looking at global system integrators. We're looking at open source companies. So we're looking at a full range of customers and partners that would be interested to make the project that much more successful. And this space is continually growing and improving.
Great.
I want to add one more comment before we get away from there. This is an open source project, vendor neutral. So it wants to encompass hardware vendors, software vendors, different end user communities, and different end use cases. So the more people that join us, it's going to just enrich this project and make it much better. So every piece of software we want to be able to, and this will come across even in the demos, that will work on different hardware, different environments, on-prem, in cloud, etc. Thank you. Okay, a bunch of links to get connected.
Yeah, so
And
this
we
is
have
basically
a community coming.
Yeah, this is basically everything about project on the GitHub or the wiki, or opia.dev is sort of our primary website where you can talk to us, reach out to us. If you know anybody who's in the Bay Area, when we are planning to make that event a virtual event now, we're having a OPIA Community Day next week, July 16th and 17th. So folks can join in, and then they can register for it and participate in the conversation. We'll present the full technical roadmap, get feedback. What are we doing right? What else we need to do? What do we need to improve? So truly running it in an open manner.
Great. Truly open source. Great.
And that's the way, it's a global challenge. Why would you do it otherwise?
Sure.
All right, so now we get into some of the nitty-gritty details of it. And what we want to show today is a bunch of OPIA demos on how you can get started with it, right? And as Zive talked about sort of the roadmap part of it, we are starting with RAG pipeline, but we have a lot of different components that we want to add to the OPIA. So today what we're going to show is focus on the use case of RAG pipeline. What is a RAG pipeline? Is basically retrieval augmented generation, as Zive explained. essentially what you're doing is you're building your pipeline. You can take a LLM, run AI on top of it, but that LLM may not know about your business context data. And so what the RAG pipeline does, it allows you to inject your business context data into that LLM and make that query more worthwhile. So for example, let's say you're a hospital. You cannot release the patient information outside, but you want to use the LLM. So what you can say is, hey, I'm going to download that LLM and I'm going to inject my patient information into it. Now the queries that I'm doing is combining the two, and it's very worthwhile to me. I don't want that to go public, for example. So you have full control of your data. And medical is just one example I've given. We have thousands and thousands of PDFs sitting in our emails and all over the place. That information, again, is your business context data. How do you make an LLM work in that context is sort of what we're going to talk about, okay? And today our goal is to show this on Intel Tiber Developer Cloud, which is a developer cloud that we announced last year. We want to show this on Red Hat OpenShift AI, and we're going to show this on AI PC, which is a brand new category of PC that we co-announced with Microsoft last year, which is what I have here. Mm-hmm. And then we also want to show this on Kubernetes, which really allows us to go across a wide range of cloud service providers. The example that we have today is going to be using Amazon EKS, okay, but it is truly upstream compliant, mm-hmm, so you can use any Kubernetes service provider over there. So let me walk you through the OPIA architecture a little bit, right? So what we're going to do here is, in terms of the supported microservices, Malini walk you through the different microservices that we have. So we have an embedding microservice, a data preparation microservice, LLM microservice, vector database microservice. All of these are different microservices. And if you take that into a technical detail, these microservices are really translated as a Docker container. And then they're composed. They could be composed either using Docker Compose, which is a technology that you use to compose multiple Docker containers together, or they can be combined, orchestrated using Kubernetes. And so those are sort of the two primary technologies that we are using. So what happens is the user makes a request as an HTTP request. It goes in to the OpenAI GenAI service gateway. And then from there, it goes to a mega service, which then kind of calls all these different microservices, which are sitting in the backend, consolidates the response and bring it back in. And on the top, what you're seeing is sort of the pipeline configuration, essentially, where you have sort of the opia.yaml, which talks about how these microservices are going to get deployed over there. Okay, so let's dig into it. Let's talk about what is Intel Tiber Developer Cloud. As I said, this is the developer cloud that we launched at Intel Innovation last year. And really what we are offering is cloud services for AI. So you can go to cloud.intel.com to learn more about it. And what it gives you is early access to Intel hardware and software. Like we make the chip, and by the time the chip goes to a cloud service provider like Amazon or a Microsoft or a Google, it takes some time because they've got to do their own validation. Here, we're putting that early on so that the customers have access to the latest chip and the software that we have optimized for it out there as well. So it's on the upstream, but we're going to make that software available to you here as well. And then, of course, we have AI accelerators and GPUs at scale. These are all Intel hardware, essentially. So that's sort of what we are making you available as part of the Intel Tiber Developer Cloud. So early access to Intel hardware, you train and develop on Intel, and you can deploy at scale on Intel hardware as well. And if you, by no means we are restricting you to Intel, it's very open source. You can create a script, a Terraform, whatever you want to create, and that's how you deploy. And if you want to scale beyond Developer Cloud, you can certainly scale to other CSPs as well. But of course, the benefit that you get on sort of the latest hardware is on Intel Tiber Developer Cloud. A very simple landing page. You go to cloud.intel.com. You register for the account. You log in. You get all the latest updates over there. Then you got all the account administration over there, a documentation page, and a service desk. But what we're going to show today is exactly how we deployed the service, mm-hmm, the OPIA examples on Intel Tiber Developer Cloud.
Great. And I just want to clarify there for the participants that this is one cloud provider, so it's one option, but we're not locked into using.
Not at all. Not at all. I mean, you can use any cloud service provider as a matter of fact. The biggest advantage is because you're using the latest hardware which is available here. which is also available in a lot of other cloud providers as well.
Just quick question, is there a cost involved or how is this access to that cloud?
Yes, it's a cloud.intel.com. You can get in, and if you want to try it out, reach out. We'll happy to give you some credits to get you started as well.
But I mean, there is a paid service eventually.
That's correct.
Okay.
That's correct. So cloud.intel.com is a CSP. It's like a cloud service provider, like any other CSP.
But very competitive prices.
Yes.
And what I'm showing here is what kind of instances are available, heavily made for inferencing, but we can create really large systems as well for training as well. And you could run up to a 7 billion parameter, which you can actually run on a desktop as well. Or you could do hundreds of billions of parameters training, multiple Gaudi 2 system where you can create a large rack, and then you can train your systems, LLMs right out there as well. With that, I'm going to actually go to Abby, who's going to show how did we deploy this cluster or this OPA example on the Intel Developer Cloud. So I'm going to stop sharing, and Abby, you can go ahead.
Yes, and for time's sake, we're at half of the event. It's 1 o'clock right now, so we have 30 minutes. It will be nice to get 10 minutes at the end for questions.
Yeah.
So
Do that.
thanks, Abby.
All right, Abby, go ahead.
Thanks, everyone. Hi, my name is, good morning, good evening. My name is Ebi. I'm one of the software engineers at Intel. I have prepared some demo for you. I'm going to turn off my camera because it might become distracting while I do this demo. But if you have any questions during the demo, please post them on the chat. Either me or one of us would answer that during the demo or after I finish and I look at the questions. Thank you. So as Arun mentioned about Intel Developer Cloud, it's very easy to reserve VMs. As you mentioned, you log into cloud.intel.com, and from there you either sign up or sign in if you already have an account. From here, there is a wealth of information on what offerings are there. I leave that to users as exercise, but in my case, I have looked at here for what's available to me, and then
Abby, I'm going to interrupt here. We're not seeing the screen that you want to show here. We're seeing your Teams chat right now.
Oh, sorry. Let's see. Let's do the right screen. Oh, sorry. Looks like it's actually sharing the wrong screen for me. Okay, I'm really sorry. Are you guys seeing the right screen here?
We got it.
Yes.
So,
Thank you.
as Arun mentioned, so cloudintel.com is where you navigate to this page, and then from there, let me actually sign out and and go back again. Like every other provider, if you don't have an account already, you sign up. In my case, I've already signed up, so I'll log in with my account. Sorry, I'm an employee, so I'm going to log in as employee, and right there I'm I'm presented with a wealth of information, what services are available for me, how much credit I have, how much I have used, and then what mechanism I use to log into my machines. In my case, I'm using SSH keys. You guys are familiar with it. You can upload keys. You're there. Everything is very similar to other providers, especially Google or Amazon. I have I have a couple of options here for me on the hardware catalog. I can either choose virtual machines or bare metal. The difference between the two, as you see, the bare metals are real hardware machine. The VMs are virtualized or chunks of a available system. I have two machines already reserved. So for different purposes, the process of launching an instance is very straightforward. You can go from there and decide what hardware you're interested in and choose your plan. And of course, give it a name. If you already have a SSH key uploaded, great. You can assign that to that machine. Otherwise, you can give it a new key. And once you click launch, your machine would become ready. I noticed in my case, it took less than 5 minutes for this machine to be provisioned, and I was able to log in. Having said
Avi,
that,
I would say take 2 more minutes to wrap up the demo because we've got 3 more demos lined up after this.
oh, sure, yeah. So let's. I have this this machine already provisioned and logged in. Let's go back to the chat Q&A. This chat Q&A is a mega service consisting of about 10 or 11 containers, depending on how you're going to deploy it. I deployed it with 11 containers because there are two UIs. The process of creating the containers is very straightforward. There are commands to build them, or you can actually pull the containers. They all have been published on the Docker Hub. I published this last night, so you don't need to actually build these containers. You can just pull them. I have the containers all running here, as you see, and I'm going to jump into actually the microservice orchestration. The microservice orchestration is handled by Docker Compose. There is a Docker Compose in here that this file has hints on what containers to be started and what ports to be listened to. So all of that information in this is in this Docker Compose, and to start it, it's very simple. You just do Docker Compose up. You can run it in the daemon mode, and now you have all your containers running. Or you can do Docker Compose -f this Docker Compose file ls, and it tells me there is one orchestrator running with the name of Xeon.
Avi, I just wanted to pause there for a second, just to so when I was when I went to your repository and I was trying to navigating it, I went into the example implementations, and I had two choices. I had the Xeon or
Gaudi.
Xeon plus Gaudi.
Right. And so Malini explained to me that Xeon is when we're using CPUs, and the Gaudi is for GPUs.
That's right.
So I think some people who are not familiar with the chipset name brands. So if you're trying this on CPUs, use the instructions for Xeon.
Right.
Right.
So
thank you for clarifying.
Exactly. Go ahead, Arun.
No, I was just saying that Xeon is a CPU brand name and Gaudi is our AI accelerator. So depending upon what you want to do and how you want to accelerate it, then you can use the right instructions essentially. And the beauty of open source is, these projects, these containers are now pushed into the Docker Hub. So it only simplifies the instructions further. So those are the kind of contributions that we would love to see as you continue to try out these examples.
Exactly. So let's go back to the demo. There are some smoke tests you can run to make sure your services are running. These are simple, good old curl commands that you do a post on your endpoints. Most of them are pretty straightforward. We're not going to go through those, but they are good exercises because it would do a quick check whether your service is running properly or not. And that checking basically means looking at these endpoints, making sure networking is working properly. And if there are any issues, you can always look at your logs. So going to
we're gonna 30 more seconds to wrap up the demo.
Sure. Oh, sorry. Sure. Yeah. So we're gonna actually look at this conversational UI, and in here I prepared some questions. As Arun mentioned, you may have some proprietary data that you're as a knowledge base that your model is not aware of yet. I don't have any proprietary today, but I do have these OSPOs for good event. My model doesn't have any knowledge of this event right now. If I ask it, it's going to tell me, no, this event is not announced yet. And I don't know, I could ask it another question. but you get the idea. In order to give some knowledge to this event, I can go and upload a file. I have this PDS, it's the flyer for the event, and I'm going to go ahead and upload it. It'll take about a minute for this file to be uploaded. And once that's done, I'll go ahead and basically, let's see, let's go and ask that question again and see if this time my, if this time my, yeah, let's ask this question again and see if my model knows this time about the event. So it's processing the data right now. Oh, actually, it's telling me that the event now is announced for 9th and 10th of July. Let's ask another question and see if this model knows. I'm gonna ask if Arun is in the panel. So it's gonna take. Oh, so maybe this content is not updated yet. Let's ask it again, because
I think the important part here that we are trying to highlight is the business context information. As you said in the morning, there is nothing intelligent about AI. It's only about the data that you feed it.
Yeah. So now, as soon as I started a new context, because the knowledge is being gathered by the model, now it tells me, yes, Arun Gupta is mentioned as being in one of the panels during the event. So the model is slowly building the knowledge and providing with accurate information. As I mentioned, this data, there is nothing proprietary about it, but think about if you have medical data or some business critical data, it could be very useful. I think that sums up my demo. If you have any questions regarding this, I'm going to mention one last thing. For me, from the minute I started reserving my VM to the minute I was able to actually get these results and I'm not a very fast developer. It took me about 1 hour to build all my containers from scratch, get my UI ready. And then, of course, I had to learn about this UI, and that took me another hour. So within 2 hours, I was actually becoming very productive. And that sums up my demo. Thank you.
So I want to just be provocative and ask a question. So if I go to the net and I say, how do I code a RAG pipeline? I would find lots of tutorials on how to do it with Olama and Streamlit. And then also in 1 hour, I can produce my early prototype RAG app. Here, in contrast, you have 7 virtual machines or 8 containers. Sorry.
Right.
Why are you doing that?
Well, I think the beauty here is the pluggability part of it, right? Because you have like 8 to 10 microservices that are sitting at the back end, and then you can swap out, because once we agree upon sort of the standard RAG architecture, that this is what the core components of RAG, today you're using Olama, tomorrow you may want to use a different underlying LLM model. You may want to use a different vector database, as a matter of fact. So that pluggability and the swappability is something that we are working on within the OPA architecture itself.
Okay. What about scalability?
Malini, you want to address the scalability part of it?
Yep. So, an environment like Kubernetes, you can say, if I have a certain amount of utilization and it exceeds that threshold, create another instance, and it just does that. It's called horizontal pod scaling or auto scaling. So not an issue at all. It's just that you should have the credit card and the money to scale as you need to meet your load requirements.
Yes. And so just following up on that. So every time I deploy, do I need to use Kubernetes, or can I first do a simple implementation without Kubernetes?
Yeah, but
absolutely can do a simple implementation, and that's the next demo.
Right. No, that's exactly how it works. You are, as a matter of fact, this is the AI PC. This is a new category of PC that we announced. it's a Intel and a Microsoft joint effort.
Arun, we have to change the screen sharing.
No, we will. Yeah. So so essentially, what you do is you do develop on a local laptop, on a PC or a MacBook, and then you say, I want to go now deploy it on a cloud environment, and then you scale essentially. And that's the beauty that Kubernetes provide across the compute layers. So, and as a matter of fact, this is something that Julie is going to talk about a little bit. And I'm going to go back to sharing my screen and give the mic to Julie.
Sounds good. So
Julie,
yeah, we'll talk. Perfect. We'll talk about doing this same demo on Red Hat OpenShift AI. Red Hat is one of these OPIA partners, and they have a OS specifically designed for AI called OpenShift AI. It's for the full AI lifecycle, and it's built on top of their Red Hat OpenShift OS, which is still a full developer lifecycle OS. So it's designed for developers and DevOps engineers. So developers can, build their applications, create all the tools and libraries that they need, create packages so that DevOps engineers can deploy these, can scale these and manage these in a production environment. And then OpenShift AI just adds the AI into that. So now you can have your data scientists that can train your models and tune your models, and you can have the MLOps engineers serving these models for inference by customers. And they can also monitor these models to see how they're doing. And, is it performing as we expect? Is the quality right? Do we need to go back and retune or retrain? All of this is provided by OpenShift AI. And it's really an OS designed for flexibility and empowering those data scientists. And you'll see this on the next slide. I'll talk through all the components that are part of OpenShift AI. So I'll go ahead and go to that next slide and talk through, these are the key components in OpenShift AI. Like I mentioned, it starts with a base of OpenShift at the bottom, and then there are operators on top, and operators really provide some key functionality that is required by the OS. So from left to right, these operators start with more of the model developer data scientist operators that let them do their job, moving on to the model serving and allowing for inference operators. And then Prometheus, that's really for the model monitoring that provides that functionality. And then if you move above that, the model development and training, this shows you what I was talking about the flexibility. You can see in the workbenches box, there's many different workbenches that data scientists or AI developers can use, which support many different hardware types, including Intel hardware. So multiple choices here, lots of flexibility. They allow for distributed workloads. So KubeRay and Codeflare will let you distribute your workload either across multiple GPUs or, for Intel, multiple Gaudis, or across multiple nodes, multiple CPUs, so multiple Intel Xeons, for example. And then model serving is also provided by OpenShift AI. It provides K-serve for single node model serving and model mesh for multi-node model serving. And then there are serving runtimes. There's OpenVINO model service, OpenVINO being provided by Intel as a way to do inference anywhere, TGIS, and also what Philip will show you is how you create a custom model serving runtime, which we did for serving models on our Gaudi accelerators. And then for model monitoring, I mentioned there's Prometheus, and this lets you monitor those models, see how they're doing, see the performance, and see if you need to go back to retraining, retuning. So that's it for this slide. I'll move on to the next slide. This is what Philip is going to show you, is that demo that he and the team have put together. And it really walks through that flow. If you look from right to left, this is what we were just talking about the model developer lifecycle. They choose their model, they choose their workbench, they can store it in S3-like storage, and then they serve it. And Philip will show you, we're serving it across 4 different Gaudis, one model on 4 Gaudis, another model on 4 Gaudis, and they're attached to one with a RAG backend, one without the RAG backend. So when the user queries, you can see both results with RAG and without RAG. And without further ado, I'll hand it over to Philip to give that demo.
Yes, hello everyone. I
have the video for that, actually.
Yes, and we have 10 minutes left in the session, so let's try to do it in 5 minutes if possible.
Yeah, we can wrap it up. So, Philip, you want me to play the video?
Yeah, of course. I am Philip, and I would like to show to you that the OPIA stack can run on Red Hat OpenShift. We have a demo that is based on Llama 2 70 billion model. Chatbots are used to offer a more user-friendly and a more accurate use case. And the demo we are presenting used a RAG and a no-RAG example that was interfaced by the user, and user could compare what was there. Some operators are used to get the Intel Gaudi accelerators available, Habana kernel model, and some other. And we had developed a suitable serving runtime that develops the model, and an accelerator profile on OpenShift AI is used to show the model, shows on what devices to run the model. Here are some OpenShift AI components. Here's the model server and its definition that we actually use to deploy it on the Gaudi cards. You can see that it is configurable, and the 4 Gaudi cards are assigned to the specific model. There are some services, the 2 backends that that are mentioned in the diagram. A Redis database that is used to hold the RAG data, also an UI, and yeah, and that is the process that the request goes through. User sends the query that gets fed to the embedding. It gets calculated, and proper data gets retrieved from Redis. Here we can see the summary of Gaudi 3 accelerator performance. And I would also like to mention that you should, of course, you should visit opa.dev and keep updated with the GitHub repositories for OPA project. Maybe you can pause now, I think, Arun. Let me just add a few more words.
Thank you.
Yeah, what is important is that this specific demo diagram is based on an older version of OPA, but we are actually working to push through the door a validated pattern that automates deployment of a full microservices-based OPA stack that should be easily adaptable to any existing OpenShift environment with OpenShift AI.
This will be all available in the repo that you can download, reproduce, exactly do the whole thing. Awesome.
Exactly.
Because of a shortness of time, I'm going to crisply move through. Michael, can you talk through what AI PC is? We're going to maybe skip the demo part of AI PC because it's exactly the same demo. But Michael, can you talk about what AI PC is?
Oh, sure. Yeah, this is Michael Lee from Intel. So I'm very excited to talk about the AI PC. This is the Intel is honored to lead the AI PC transformation by making it easy for our software ecosystem to develop and deploy new and enhanced AI experiences and provide a scale to reach the masses. And it all starts with our new Core Ultra processor. We launched it back in December in New York, and we are very excited about this platform. The platform has a new integrated neural processing unit, NPU, to go along with our CPU and GPU. Each of these processors bring unique strengths spanning fast response time, high throughput, and low power. This enables the independent software vendors, ISVs, and software developers to match the right workload with the right XPU to deliver the best user experience. Our Core Ultra processor is also up to 36% more powerful efficient versus our prior generation, and also delivers 2x the gaming performance. It includes the Thunderbolt 4 and Wi-Fi 7, and up to 70% faster generative AI performance, taking advantage of our GPU and NPU. To bring this to the market, we work closely with the top 100 ISVs, so their software application can benefit from faster performance, lower power consumption, and most importantly, scale on 100 million AI PCs that we will drive by 2025. So I'm going to talk a little bit about the AI PC developer program to support our AI PC launch and the overall AI PC platform. To accelerate the AI PC software ecosystem development, we launched the AI PC developer program in March. The program is focused on developers who are a critical piece in helping drive new and innovative usages, features, and experiences for the AI PCs. We are drawing from years of experience working with developers to ensure they have what they need to unlock even more software benefits on the AI PCs. Our goal is to accelerate application development, provide the developers with key resources, and drive a consistent, seamless, and frictionless experience. Our developer program centers around a few things. It offers choice among frameworks and libraries, ranging from OpenVINO, Onyx Runtime, DirectML, and WebNN, and more coming soon. And tools and workflows for AI deployments with sample codes and use cases so that developers see a faster path to production code. And models that are optimized across the Intel CPU, GPU, and NPU so that the right workload runs on the right XPU. And at the last count, we added up about 500 optimized models, right? That are optimized on the Intel platform. Another key part of our developer program includes the access to a development kit, dev kit. The current generation dev kit features the ASUS NUC 14 Pro, which is available now. And the program also offers the early access to upcoming dev kits on future platforms. So these dev kits are AI ready with a pre-installed software stack, drivers, and host of other programming tools and compilers to get developer going. And last, our knowledge center, a one-stop shop that builds on our legacy of key information and training content, and is now updated with our latest news for developers. So check it out and join our programs.
Yeah, thank you, Michael. So I think I'm gonna put a pause here. This is the exact same demo that we could have shown on AI PC. It basically talks about how we are using OLLAMA, which is like a small size LLM running on this machine instead. And then the last piece that we really wanted to talk about quickly, Malini, I'll give you like maybe 30 seconds to talk through the relevance of OPA on Kubernetes, and really wrap it up in 30 seconds because we want to keep a few minutes for Q&A. Yeah.
Sounds good. So essentially, we created a Kubernetes cluster on AWS EKS. It just took us like 12 minutes to set up the cluster, put in an instance that was large enough to run an LLM. And
Malini,
lo and behold, we had it.
Just for the sake, could you also say in 10 seconds what is Kubernetes for those who are not aware?
Oh, yes. Okay. So typically, when you have an application, it might not all fit on one single computer. So what happens is we talk about a cluster of computers or nodes. These can be virtual machines or physical machines. And then when you need to orchestrate your workload on this cluster of machines, you need an orchestration software. And the most popular of these is called Kubernetes. It's an open source project with thousands of developers and a very large community, very well documented. So that's the value of Kubernetes. And that's why we're talking about deploying OPA in a Kubernetes environment. And just about every cloud service provider offers you a Kubernetes environment, including Intel, Tiber Cloud, Google, Amazon, Alibaba, just name it. And that's why we said, hey, how do we demonstrate that OPA works in any CSP? And we reached out and did it on an Amazon EKS. It's the exact same demo that Abby showed. It just runs and it was seamless. And what we did use is something called Gen AI Microservice Connector. And we have a demo recording, but no time to show it. It connects these microservices. It enables reuse of these microservices. So suppose Jorge had an application pipeline and Arun had one, and they both needed to use the same Mistral model. It can be reused, and that's the beauty of it. And an earlier question about scalability, if the same Mistral model was being used multiple times, the load was increasing, Kubernetes out of the box offers you horizontal pod auto scaling. If you've kept some criteria, 90% utilization, pop up another instance up to a max of say 10 instances, all that happens seamlessly.
I would say the biggest benefit of using Kubernetes is, we showed you a native demo on Intel Developer Cloud, but Kubernetes is available on Microsoft, Amazon, Google, pick a cloud service provider. So it allows you to run the OPA samples very cleanly on those CSPs.
Yeah, I mean, actually, that was going to be my question. So can we have access to the demo? Because we work with Kubernetes in AWS, and we would really like to try it.
Yeah, no, absolutely. These instructions are actually available on the GitHub repo right now. And so what I'll do is after the talk, Jorge, I'll send you a link to all the 4 demos so that how the team and everybody who attended the webinar can reproduce it. And we would love to see your feedback. What can we do better? What can we do simple? How can we make it more engaging? Send a pull request, as we said. Now, we would love to get your feedback on that.
And all that, I understand, that's for us to reuse as well? Like, say, we can start from there and start building those things. Like, this is all open source.
Yeah, absolutely.
Yeah.
Absolutely. You can take, and the whole idea is you can take a look at all the microservices that are building that demo, and you can say, oh, I don't like this particular vector database. Instead, I want to put my own vector database, or I want to put my business context information. So that's sort of the starting point for you.
So I think we could talk about this for another hour, but we don't have time. And it's also we're asking for a very hard bar to compress a lot of information in 1 hour. So I just want to stop it there and thank you very much for all your time, you, Arun, and everybody, Malini, and the rest of the team who are away. And I'm going to give the last word to Julia from the UN 2.0 to just close the event.
Well, thank you so much. Well, I can only speak for myself. I learned a lot, and I'm sure that all of the participants here have felt the same. So yeah, thank you all so much for joining, and I'm excited to see more of these technical sessions and more of these collaborations. And yeah, let's talk soon. Thank you all for joining. Have a great rest of the day.
Thank you, everybody.
Thank you, everybody.
Thank
Goodbye.
you, and thank
Thank
you for
you.
all the
Have a
wonderful
good day.
questions in the chat.